Hello, everyone. Good morning, good afternoon, good evening. We have folks joining us from all over the world. So, wherever you're joining us from today, welcome. Really excited to see some return folks here and also some new folks joining. For those of you who are new, my name is Erin. I lead global startup programs for Google Cloud, and I'm really excited to be here with you all today as today's session host. Um, I will just run through a few housekeeping items, some reminders, and then I will introduce and kick it over to our two awesome speakers today. So bear with me for just a few minutes before we get into the good stuff, as they say. All right, so before we jump into today's session, I thought it would be helpful just to see where we are in the overall curriculum for the Startup School program. So last week we had our first sessions. So if you were with us, you know that we touched on various AI products and solutions to help you power your business. This week, week 2, which we are in currently, we are moving on to prototyping solutions, which was the focus of Tuesday's session, and now today scaling generative AI. As a reminder, next week, we will slightly change the topic to double click and deep dive into BigQuery and applications of Gemini with BQ. And then as a final reminder, week 4 is also rapidly approaching. We have our partner takeover week, and we have two fantastic program partners, Anthropic and Google DeepMind, joining us for that. All right, so let's just quickly run through startup school structure. Again, more as a reminder for everyone. So as you all know, we have our live sessions each Tuesday and Thursday, same time each week. For anyone who's new or didn't hear, all of our sessions are available on demand through our main landing page and website. So you can take your time, you can rewatch something. If you missed a session, you can go in and check out what you missed. All the sessions will be available on demand a few hours after the live session ends. So go back and check. If for some reason it's not live yet, check a little bit later and it should be there. Two other main components of the program are Cloud Skills Boost, which I'll get into in more depth in the next slide, but essentially recommended labs for follow-up and continued learning. And we give you access to try these technologies and solutions for free so that you can practice with guidance. The link provided in number 2 on this slide is the list of labs to check. Again, I'll go into more detail on this in the next slide. And then related to that, you do have the ability to earn skills badges when you complete some of the labs. So for those of you who are competitive or like getting accolades, that is an option as well. All right, so Cloud Skills Boost. As mentioned, we are using practical labs as a key component of the overall training program. To be able to access these labs free of charge, you do have to fuel your account with credits via the Cloud Skills Boost platform. So everyone should have received instructions by email on how to activate and top up your account with these credits and your unique code to obtain these. For anyone who recently registered or maybe missed that email, you can scan the QR code on the right that you see on your screen right now to activate your account and redeem the credits. You can also use the link that you see in the first bullet point here if you're not into QR codes. So last but not least, if you have any questions about this or you need any assistance with credit redemption, you can contact support@quicklabs.com. We've also added these details to the chat space on the right-hand side. All right, a few final housekeeping items before we jump into today's class. Hopefully these will help you make the most of your time in class and at startup school overall. So as you can see on your screen, there's a chat function on the right-hand side, and there's also a Q&A panel at the bottom. We are really fortunate to have amazing Google AI experts on hand live to answer any questions that come up throughout class. So please ask your questions in either of those spaces. We do save about the last 10 minutes of class for live Q&A with our instructors. We will select the most common questions asked and those relating directly to the content that's covered today. You do have the ability to upvote questions in the Q&A panel and use the chat space to converse with other participants. As mentioned earlier, we are recording each class. You'll be able to watch them back on demand later, and you can access all of the recordings via the main program page. We will also send a follow-up email later this week with that link if you need it. We won't be sharing slides, but we will share links to the labs covered in class, again, both during class in the chat and QA panel, and then also in our weekly recap emails. If neither of those things work for you, you can also find the list on the resources tab on our website. So several places for you to find everything. And last but not least, just one more time, this is a hands-on training series. Most classes do cover a lab as mentioned. All of these are available on the Cloud Skills Boost platform or our Google Cloud GitHub repo. We do share all the links with you to access both of these. We strongly recommend using the class time to watch our instructors going through the lab and completing it after the session. I should have mentioned earlier, the credits that we provide for Cloud Skills Boost will last you the full 4 weeks of the program, so you have plenty of time to do this after class. And with that, I think that's it from me. I'm really excited to invite our two speakers, Maruthi and Naresh, to our virtual stage to lead today's class. I will see everyone a little bit later for the Q&A session, and I hope you enjoy.
Thank you, Rin. Hey, everyone. This is Maruti Tumuluri. For those of you who are attending this series, you know that I'm a permanent fixture here. I'm an AI engineer here, focusing on generative AI of late, and particularly focusing on agents and production systems. We have a pretty dense content today, right? And also we have a lot of labs that we have attached as links, right? So we'll kind of go fast. Hand over to Naresh to take it forward.
Thank you so much, Maruti. And I know that you have been doing a lot of these sessions. Again, thank you so much. Can we get our slides up as well? Wonderful. Hello, everyone. I am Naresh Jasotani. I'm the principal technologist for automotives here. I'm based out of Detroit. I have published a couple of books, Blockchain Beyond Basics and Adopting TensorFlow for the Real World AI. And I also work with a couple of universities to design and deliver machine learning courses. Now, with that said, let's kick off. As Maruti said, that we have a packed agenda today. This is going to be an advanced, quick, highly intense session. Obviously, you can go back and watch the recording. First, we'll start with Imagen 3. I know that we have had a session on Imagen 3 already, where we talked about what all is coming new and what betterment in quality Imagen provides. I'm going to talk to you about productionizing Imagen 3 based applications and any work that you're doing. I'll then start with advanced Gemini capabilities, things like agent builder, function calling, context caching, prompt tuning, and things like that. Then I'm going to hand it over to my friend Maruti for function calling and AI agents. And then he's also going to talk about optimizing things for production. With that said, let's kick off. Okay, so this is at a very high level, a view of Imagen 3. And people who are joining here us for the first time, Imagen 3 is our image generation, image editing model, which is brand new, and it is available on Google Cloud. As well as I'm going to show you some resources. So as part of this session, we are also going to share a lot of resources, materials, codes, and platforms that you can quickly go use and get yourself comfortable with. Imagen 3 obviously provides image generation, but it also has safety filters like block of certain inappropriate things, or do not allow any human faces, or allow adults only, or all faces. I'm going to show you some safety filters as well. In the editing section, you have in-paint, out-paint, new additions to the model. I'll walk you through the console as well. And then you have few shot customization. What if you have a set of images that you have been working for the last decade or even beyond, and you want to use the templates, you want to use those images, train or fine-tune a small Imagen model to work on your data. So, as we do customization, fine tuning with the prompts, we'll do that as well. Now, Imagen 3, the one of the biggest thing on Imagen 3, and I'm going to show it to you as well, as I said, it's able to generate images based on aspect ratio 1:1, 9:16, 16:9, different portrait, landscape, different sizes. You have editing capabilities as well, in paint, out paint, background, and control editing. You can remove people, as many of you might be using Google Pixel phones. They have an inbuilt capability of erasing out people. If you're taking a selfie and you want you and your friend to be in the picture and all the strangers from the images can be removed, that functionality is also added. And then you have customization. That is going to be my focus today. You can customize a model, augment and tune images for operating in your domain on your images. It's going to generate images similar to what your images look like. So let's quickly look at that. Imagen 3 also has lots of functionalities like close-up images. Like, for example, if you want to say close-up of a bean, coffee bean, or for example, the close-up of this blanket or chair. You have DSLR photo size, you have sketching, you have bright. You can prompt tune different varieties of camera angles from the top or very close up or landscape view. You can define the focus, sharpness, and resolution. I'm going to skip a few slides. The best thing about Imagen, it has come up with two different types of models. I know that this was covered the last session as well. I'm just repeating it for a quick recap. Imagen 3 Fast and Imagen 3. Those are the two types of models. Based on your use case, based on the costing, the fast, as you would imagine, it's going to generate the images faster, but some of the details might not be as proficient, as impounding as Imagen 3, the bigger version of the model is. And it's not very different, but from a costing and the speed wise, it's a little different. There are a lot of editing options. I'm going to show it to you in a few minutes. In paint, insert, in paint, remove. So for example, look at this. You have added few leaves, a little small plants in the second image. In this image, you have removed all the strangers. Out painting, if you look at this one, it was just an image of Jupiter or this planet, and now you have an image of surrounding as well. So it's a bigger image, and then you have image editing. For example, this chair, just highlighting the chair and changing the background a little bit. You can add using mask. You can mask a certain piece and you can add different objects there. This is another example. You have an original image like a ball, and then you can create an edited image of this ball, but deflated. And so on and so forth. You have so many options. You can actually create a sketch image and then convert that sketch into a real photo. Like, for example, this bike or the bird here. But let's talk about customization. This is very important. There are a lot of use cases around media, consumer applications, retail, around customizing your brand content. This is the advanced version of the Imagen. You have a product which you sell, and you want to highlight that product in such a way that it is very personalized, but it has all the generative AI capabilities. You want to highlight a subject. For example, in this image, you are highlighting this player. You know what? Slides. Let's look at the real thing. Let's quickly switch on to this. Look at this. We have, and I've already generated this beforehand, but when you go to Google Cloud Console, it's very simple. Go to Google Cloud Console, search for Vertex AI, that is the service, and underneath the Vertex AI, you have Vertex AI Studio. In the vision where you are going to get your Imagen 3 model, you would see Imagen 3 and Imagen 3 Fast. This is a cinematic shot of a person playing a mournful melody, and then eyes closed, and you define what you want. And you look at this, the types of images it has created is really cinematic. Let's look at other one. This is what I was talking to you about product personalization. I am focused on this sparkle water product. And this sparkle water product should have my name on it. And I don't have a company that sells sparkle water, so I just put my name on this can. So it can generate images, your brand images with different background, different features. This with a different aspect ratio, and you can then edit those images to add more. And then I'm going to show you this as well. This is my favorite. I have used Imagen 3 fast model on this one. A professional photograph of a family of 4 people around a campfire outside an RV making some more s'mores and admiring fireflies on top of them. So look at that. This is what I mean by next gen Imagen. You can describe exactly what you want to see and you see it. Well, this is on Google Cloud and you have access to the labs. But there are people, there are developers out there who want to try out. I want to try out. I want to see this. For them, in a few minutes, we're going to add all the links in the chat. But first of all, I want to show you this DeepMind technologies. If you go here, you have all the types of models, Project Astra, VO. This is deepmind.google/technologies. You can try out Imagen as well. You got a request for a whitelisting and you will get it. So this, I'm going to share the link in the chat in a few minutes. And then you have this AI test kitchen. This was launched some time ago, and it provides you an ability to generate music, lyrics, videos. So if you click on music, you can generate this music, a jazzy piece with a smooth saxophone solo. The sound is both sophisticated and playful, even though I wasn't planning on covering the sound, but I couldn't stop myself not showing you. So again, AI Test Kitchen and DeepMind.Google, please understand that these are a consumer application, not an enterprise. What I really mean by this is because it's free and for you to use, please do not prompt with some proprietary or PII data. This is for you to test it out. If you want to work with private data, obviously you want to use Google Cloud. So Google Cloud provides you the enterprise version, but those are a couple of options for you to explore if you want to just do some research. So coming back, how does few shot customization works? Load up to 4 images, assign subjects and reference ID, and then you generate the prompt in such a way that what you expect your user to generate, and at the end a new model is going to be created which is going to perform very closely to what you expect your image, your brand to have. So again, API for this is available. I'm going to share you the code where you can try these generative AI, Vertex AI Creative Studio. This is the GitHub link of all the codes, and you can try it out here. Again, as I said, all of these links would be shared in some time. Now, I'm going to quickly pivot. So these are some resources, helpful resources. DeepMind, AI Test Kitchen, Google AI Studio, which I'm going to cover in a few seconds as well. Vertex AI Creative Studio, where you can go and try all those images and fun stuff. I have this GitHub. This is my personal GitHub. If you remember in my introduction, I mentioned about I being a YouTuber, and I have a YouTube channel where I put all things AI, Gen AI related. So this is a GitHub link that provides you the code of a lot of things that we are seeing in the market, specifically around agent builder with YouTube links, as well as step-by-step instructions on how to do things. So for example, BigQuery structured Q&A or external APIs, all within agent builder. I'm going to cover agent builder in a few minutes. Now, I am going to focus on advanced Gemini capabilities. Please keep your questions coming in and we will answer a few questions at the end of the session, and obviously our moderators are going to help respond on the chat as well. Now, this next segment is going to focus on Agent Builder Advanced, going to focus on prompt tuning, going to focus on context caching and function calling. So I'm going to build this segment up for my friend Maruti to do his segments focused on how do you productionize a generative AI application. I was in a meeting yesterday and I mentioned to one of the execs, and this is my favorite. Gen AI is that Ferrari. Everybody has a key, can get in and start the car. But there are very few people and organizations who know how to drive this car so that you can achieve your objectives. So generative AI, even though it's a great technology, no doubt, and obviously we earned bread because of generative AI in the last couple of years, but it's more important for us to understand that the productionizing of the applications, the value of Gen AI can be only unlocked when you have a very clearly defined metrics and how to use small little things like context caching to save cost or function calling to make the entire system more good in a good experience, have a connection to external systems as well. So having said that, let's go look at it. Now, back in May 2024, earlier this year, Sundar Pichai mentioned that the world is moving towards agent. And I shamelessly took this screenshot when he was presenting on the stage because I love this. And this is one of the most easiest way to describe an agent. An agent is that piece of an application that has reasoning, planning, and memory. That means this agent, this model, this tool, this software can do a very human-like reasoning. It can plan ahead, and it has a memory too. Normally, I run a video before I come here. In the video, Project Astra, search it on the YouTube. This person carries a cell phone and it points to various different objects lying on a table. And when this person asks, have you seen my glasses? The model tells you, oh, your glasses were on the right side of the table next to an apple. So it has reasoning and planning with memory. This agent can think multiple steps ahead. Gone are the days of entities and intents, and you define all your chatbots. This is generative AI era. You are defining your agents to be much more intelligent. Next, these agents have an ability to work across softwares and systems. I'll give you an example. If you want to find out your shipment coming in from Amazon or eBay or somewhere else, the latest information could be in Salesforce or some shipment tracking platform or somewhere else. How can you enable this agent to go and tell you the latest status of your shipment or your ticket? Or the latest and greatest information can only be obtained when you have connections, APIs, an ability to generate and have an experience more from a agentic flow perspective. So I'll define this. An agent can observe, act, and achieve. This is a definition of generative AI agent, is an application that tries to achieve a goal where it has tools like RAG, or as I mentioned about ticketing systems, or Salesforce, or ServiceNow, or Jira, or SharePoint, or OneDrive, or Google Drive, all of these access creates a cohesive environment for this agent to complete a task end to end. Let's look at why we are talking about agents. So back in 2022, September-ish, there was this Chat GPT or Bard from Google, which came out. Probably Bard came out a little late, but all we used to do is ask a question and you may or may not get a response. I'll tell you a very funny story. I have told this multiple times. LangChain wasn't a thing that time. So I asked a question, and this is real. I asked a question that what is LangChain? And obviously the model hallucinated because this was trained up until a certain point in time. It told me that LangChain is a type of blockchain, which is completely wrong. But the model wasn't trained on it. So let's take an example of LangChain. I'm going to ask this model, what is LangChain? And it is going to give me obviously hallucination because the model, when it was trained, LangChain wasn't a thing. Now, then came the era of RAG. We have been doing RAG applications for the last 2 years, wherein you enhance the data and the model capability to respond to your specific questions based on your data. So for example, if I ask, what is LangChain? Because of this additional data in the form of vector, RAG, and RAG is not the topic of conversation today, because of this additional LangChain data, it is going to respond back to you what is LangChain. It's a framework of developing GenAI applications faster. Let's put it that way. But then, if I want to ask, what is the status of a LangChain application or project that I'm doing? What is the current status of a project on LangChain? That may not be in the LangChain PDF or manual. That is where agents come in. As we mentioned, agents have the capability to run across systems, work across systems through APIs, RAG using vector databases, search, you can do grounding on Google search, and then Wikipedia as in ability to look at publicly available data sources. And this model is able to orchestrate an experience. So imagine, again, me being stupid asking about what is LangChain, it gives me the right answer. But if I ask it, what is the current status of the project? It's going to create an API call through the tools to go and grab the latest information of the project of LangChain, that is status. That is the agentic experience. Again, an agent has a capability to orchestrate, respond back to you in a generative AI fashion, obviously runs a model behind the scenes, but then can converse and work across system. Now let's look at how you can create agents faster. So Google has developed a platform, a low-code, no-code platform known as Agent Builder. The Agent Builder platform has the capability to work quickly and respond back to your or create an agent faster. So again, an AI agent has models, tools, and you can have memory, model and reasoning planning, and all the generative AI functionalities. So let's look at Agent Builder really quickly before we come on to other stuff. So you go to Google Cloud and search for Agent Builder. Google also does search too very well. I'm just kidding. So you have Agent Builder, and when you go to Agent Builder, you can create an app. When you create an app, you will have different types, like you can create a search agent or app, chat app, or you have an agent here. If you click on this, it quickly gives you a low code, no code platform where you can define the goal. Remember, the agents have goal. The goal is to achieve a certain task or a certain functionality. You define the agent name, you define the prompt, and then you can have different tools. Remember, ability to connect with different systems, working across systems is the tool. Now, there are multiple tools available. You have code interpreter, and then you have multiple tools like open APIs, data function, data store. Extensions are coming up very soon as well. And then you can have integrations. That means how do you deliver this to your end users through Dialogflow Messenger, which is your chatbot, your Google Chat, Slack, WebEx, Telegram, and also you have Soul Machines 3D avatar. I'm going to quickly show you uh, 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 an example here. So if I ask it, what is the weather in Detroit? It brings the current weather in Detroit. Remember, working across systems. So what is the current weather in Detroit? It says the current weather in Detroit is clear sky with a temperature of 31 degrees, and it has worked with weather. How to develop this application, how to create this weather app is available in this GitHub repository. If you go to external APIs weather, it will tell you how to create it step by step. I have a PDF document here as well where you can use it to create all of these examples. All right, let's quickly jump on. What are other things available, right? And as I mentioned, my friend Maruti is going to talk about detailed productionizing. You have prompt optimizer. When you write a prompt also is an art. Writing a prompt is an art. So when you write a prompt, there are services which can take your prompt and add a lot of things that are needed for a good prompt, and it can auto tune, it can optimize your prompt for maximum effectiveness. You have supervised fine tuning. You can tune now images, as I showed you on Imagen, text obviously, and audio as well. I believe video is coming soon. Now, these Gemini models tend to be large. You must have heard about Gemma, that is a smaller version of bigger model. But then you can create a very specific version, very targeted model for yourself. And that is known as distillation. You can model prune, you can distill, you can make these models smaller so that it can work on your data set faster and for a better experience. So again, prompt tuning, supervised fine tuning, and distillation are definitely those items that you want to look at going forward. Now, I'm going to quickly talk about in-context caching. In-context caching would be covered in detail by Maruti in a few minutes, but imagine a RAG application. Every single time you're asking a question to a RAG application, it is going and searching against a vector database. Sometimes the response of this is not as great. So what you do is add caching based on the examples, based on the questions. If it is being asked, you can cache a small data set. You can cache request and response and able to respond back to the user faster. So I'll just going to show you a prototype. When you have a conversation or a query, you ask a question to a generative AI model, and if you see that this question has been repeated, you can cache it. And once you cache it, the next time a similar question is being asked, a smaller model and the cache can respond back to the user faster. For all other queries, it will go to the vector database and do the regular process. Context caching has, we have seen a lot of savings in terms of cost because you're every time hitting the vector database in a slow process, while this cache with the context can help you respond back faster. Uh, this is how you create a context, a cache, and then update the expiration time. Now, function calling, I'm going to skip a few slides, but I believe most of you already know. Function calling is that tool which can help you connect to an external system. All you do is define your functions, define a function that can run standalone, wrap this function in a tool, and then call this via Gemini. I'm going to quickly show you a code because, as I said, it's an advanced version of this, and I'm quickly going to hand it over back to my friend Maruti here. So you define a function. So for example, remember the weather example, you define a function. So function calling enables you to interact across systems, tools. Remember agent builder. You create this function, and this function is written in Python. It takes in location lat lon, and this notebook is also available in the GitHub. This function can run standalone, right? This is an API call happening to a api.weatherbit.io. You create a wrapper. Remember the second step, create a wrapper function, define in plain English what this function does. You have another function here for time, it gets you the time. Next, you call this generative AI model and pass in the tools. The tools have the tool has these two functions, weather and time. So based on your prompt, it's going to pick one API call versus other API call. So this is function calling, as I said, is available for you. And again, a quick recap on the useful resources. You have DeepMind, AI Test Kitchen, Google AI Studio, and Vertex AI Studio with context caching. I'll hand it over to my friend Maruti to do the next leg of this session. Maruti?
Thanks, Naresh. Appreciate it. Um, so I think Naresh made my job a little easier by kind of doing the intros, right? So we can spend a little bit more time on like hands-on stuff and potentially maybe either do like a notebook walkthrough or maybe a demo, right? So let's get started. Where are we on the time? Okay, so we have a reasonable amount of time. Obviously these topics, probably each of them deserve their own kind of an hour session, right? So we'll try to cover a reasonable breadth, right? And also try to not to make it like a marketing slide deck, right? So let's go ahead. So I think, as Naresh mentioned, right, I think we are evolving from, a zero shot, few shot LLM calls to building these agents, right? And agents are getting very, very pervasive. It's no longer building a chat bot or search applications, which are still very valid applications, right? And there's a lot that can be done, right? But we are seeing the GenAI apps in particular getting into pretty deep domain areas, right? Like all the way into like healthcare systems, insurance systems. In fact, people are looking at material science, rocket building. There are like a lot of areas where the Gen AI applications are getting into. And from a startup perspective, right, I've spoken with a lot of startups over like last year and a half, right, where initially there were a lot of these LLM wrappers, right, like you add a little bit of functionality over the LLMs, right, like the foundation models, to a point where I know a few customers who at least use 20 models, right? And like innumerable number of agents leveraging those, right, for various tasks, right? So these are almost like semi-automated systems working to get through, a whole bunch of tasks, right? So it's a very, very exciting space, especially for startups, I think, right? Given its potential. What I think we see here are just a few, right? This by no means is like, a complete list, right? And I think we have the link there, which kind of talks about, some use cases, but I mean, I don't think it's like exhaustive, right? And I think this is a great opportunity for this forum to kind of innovate and show what is possible, right? So we are kind of trying to facilitate this, right, as Google and Google Cloud. But I think the startup community are like, the torch bearers, right, getting into the art of possible. A quick rehash, right, what agents are. Agents plan, reason, and execute tasks for users, right? And there are a few building blocks. We'll go through them in detail, right? But at a basic level, right? See, this is just my kind of definition, right, or my interpretation. Obviously, I don't know if there's like a universal definition of what an agent is, but I kind of treat, having come from like, a development background, I treat agent like a microservice, right? I know it's not a great comparison, but hey, you're trying to solve a problem, right? You have a few things at your disposal, right? And the thing that you're trying to solve is atomic, like it's kind of defined, right? And then you have access to data, tools, whatever, right? And then you do that process or you do that task and get out, right? And convey the results and so on. And then there's like this orchestrator thing that kind of invokes like various microservices, right? And orchestrates them and something similar, right? So for agentic systems, it's kind of similar. We'll go through some of the patterns, right, shortly. But the concept is like at a very high level again, right? It's pretty much the same, right? So you have some orchestration happening, right, which kind of plans like how these agents need to be called based on the responses that you get, like, how do you invoke the next step, right? It could be something like a finite state machine, right? Whether it's directional or bidirectional, or it can be something like a Petri net, right, where you have like, these multiple things going on in parallel, right? Concurrent systems working together and exchanging information and so on and so forth. So there's a lot of research going on those two, right? But then again, coming back to like, the basic structure, right? Then you have tools, right? Tools do a bunch of things, right? Tool can be an existing tool. It could be an API. We'll talk about some of the APIs, right? We'll actually invoke a couple of APIs and see, right, in the real code. And then you have the orchestration and the runtime. Runtime is basically, thing that gets executed. From a categorization perspective, right? Again, we are taking a snapshot in time, right? I mean, this doesn't mean that these are the only cases, right? I mean, things are already evolving. It's such a kind of hot and happening area. So it would be it wouldn't be wise to basically say, hey, these are the only categories, right? But still, just an attempt, right? So you have modality based, right, where you have text based, right, is using large language models. Then you have multimodal kind of use cases, right, like things like vision, language, right? I think Project Astra kind of demonstrates the capability of a true multi-model, multi-agent system, what it can do, right? Like going to really like real personal assistants, right, for people, right, as we get into future. So those are kind of capabilities, right? Now, if you look at use cases, yeah, I mean, it spreads across, as we mentioned, like, from gaming to healthcare to manufacturing to like pretty much you name it, you have it, right? It's a pretty broad category. The other way to look at it is like, what kind of integrations they do, right? Like you have conversational agents, right? Again, like, chats, right, where someone interacts, right, like more actively. Then you have, user queries, right, searches, stuff like that. And then there are these workflow agents, right? Workflows, right, are more, I won't say they're targeted business, right? You can have workflows like, in a consumer style use cases too. But I think um, enterprises have, most of the operations happen in the workflow kind of situation, right? Like you have step 1, step 2, step 3, something happens, you have a decision tree, then you have step 4, step 5, whatever it is, right? So you may or may not have human interaction, right? And even if you have, right, sometimes it's mostly to kind of provide a permission or, provide like, some kind of a human feedback, right? Or human in the loop and so on and so forth. Then you have categories like trigger based things, right? Like something happens, right? You get a file in, right? You process it, right? You do a bunch of things to it, right? Then send it to some other system and so on, right? And then you have like, fulfill queue task or chain apps task, right, that you're doing, which may not have like, uh, complex dependencies, right? But you're kind of taking this like step 1 to step 10 and then keep repeating, right? So again, right, as I mentioned, these are not the extensive list of categories or a list of agents, but just one way to kind of think about them, right, at this point of time. When you talk about models to agents, right, like what I'll not read this entire slide, right, kind of get the idea, right? Model is something that you directly interact with, right, and then basically get some response, right? Most of these are like singleton. Yes, you can create like bots on top of them, right? Usually they don't have tool implementations. Again, right, when I say model, right, I don't mean to kind of say applications, right? Not like a Gemini app or a GPT app, right? I'm talking about like foundation model capabilities, right? Obviously, the applications that are built on it are agentic, right? They're using a lot of tools behind the scenes, like for example, a map function, currency conversion function, right? That gets latest information. And then agents, right, as mentioned, right, so you have a lot of additional functionality, right? Some of them leverage latest data, some of them leverage private data, some of them leverage domain specific data, right? And then some of them use certain specific cognitive architectures, right, and reasoning frameworks, right, React and so on and so forth. So there's a lot of kind of difference, right? I think Naresh kind of mentioned compared to like 2 years back, and then what we have right now. So let's look at some of the foundational building blocks of an agent, right? So at a bare high level, right, you have like 3 to 4 components, right? So one is basically a model. Again, model in a true definition, right? You don't technically need to have a model, right? But as a normal pattern, because there's some reasoning involved usually, right? There is a model, right, as part of like the standard thing. You have a reasoning loop, right, where you do a lot of reasoning, right, do a lot of analysis of the answer you got from the model, right? Then you process it, you send it back, right? There's a lot of reasoning happening. And then there are these tools that are external entities that you basically leverage to get your task done. I'll skip through some of these, right? You know what a model is, right? So reasoning loops, right? I think these are interesting. They can be iterative, they can be introspective, a lot, right? Like when human does something, right, you think about it and reason about it in so many ways, right? Like you kind of think from a justification perspective, you think from a motivation perspective, you try to validate and revalidate based on the presumptions that you have or the data points you have, right? So similar kind of reasoning can happen, right? Then you can have either like a simple rule-based calculations, right? Let's say you want to compute income tax, right? Like there's like a specific formula, right? I mean, it could be a complex formula, right, based on like your income, your background, like your personal situation and so on. But it's still kind of rule-based, right? In some other cases, it may not be that simple and accurate, right? So you have to kind of do some probabilistic reasoning, right? For example, using statistics and so on and so forth. The approaches mentioned below are a few, right? But it doesn't mean they're like complete and exhaustive, right? So things are evolving, right? Like how can you split reasoning, right? Can you have concurrent reasoning capabilities? Is the reasoning serial, right? There's a lot of research going on, and at least Google from our side, we are innovating a lot, right? If you kind of follow, you'll see some updates like really soon, right, on coming more and more of these frameworks. And then you have these tools, right? This is basically, again, as I said, things that interact with the external data, extensions, functions, data stores, and so on and so forth. I'll kind of speed up a little bit because I want to spend some time on the demo. Again, like the whole concept, right? User sensory record. You go through this reasoning loop, right, where you try to understand what's going on. For example, you want to book a flight, right? So this whole process goes on, right? And then you basically get a response. Naresh covered this, so I'll skip function calling. The key takeaway, right, from function calling that I want you all to take away is, think of a function calling, right, is more of like the model, right? It returns a function signature to you, right, based on, like, you say, hey, I want to book a flight, right? Then it kind of identifies, right? Oh, maybe you want date, maybe you want like, the source and destination, right? The origin and destination, whatever, right? And then you want the kind of a class, right? Economy, whatever it is, right? A bunch of criteria, and then it would kind of come and like show you the options, right? Then it kind of creates a signature, and then either your agent or your execution kind of flow is responsible for invoking that function, right? So that's one of the key differentiator. Whereas for extensions, right, extensions are more like inbuilt plugins, if you will, right, like into systems where you want to integrate, maybe let's say to an ITSM system, right, or to an intake system, right, in an insurance kind of a setup, right, where you have predefined set of third-party tools that you want to integrate into it, right? So you have the capability, right? So most of these are pre-built, right? And one of the core difference, as I mentioned here, is like functions kind of provide that redirection capability, right, where you don't have a direct way, either because of security or other reasons, to invoke a function, right, or a capability. You basically use functions to kind of indirectly invoke it, right? And with extensions, right, they're all set, right? It's like you connect to this email, right, or you connect to like the CRM system, right, or you connect to an API, get a bunch of functionality. So that's how they work, right? Again, I think these kind of show the same process, so I'll kind of skip through them. Again, right, like the extension, at least the capabilities that we have, right? So the work on external APIs, right, that are OpenAI compatible, and work with a whole bunch of frameworks like Cloud Run and so on and so forth, right? Again, it's kind of process flow, right, for an extension. So you basically configure the tool, you pass it to an LLM, right? LLM may invoke the extension and return the response, right? When I say may, right, the may process comes in because there's a reasoning, right? Like let's say if the reasoning that doesn't mandate calling a specific extension, it won't, right? If for all the first party services that we provide, right, the APIs run on Vertex, and then it'll basically get the response back. And data stores, I'll show this in a demo, right? I think that's more effective than kind of showing here. But the idea is like, you have a bunch of documents, right? In some repository, you have websites or, public information that you're scraping, or you have more structured data, right? That's stored in like a warehouse kind of a thing, like a BigQuery or whatever, and gets the input back, right? So, and then, you basically get the response. This kind of an high-level sample agent architecture, right, where you're basically sending a question, kind of talks through the flow, right? Yeah, you can probably read. You want to set up a ski trip for your family, right? So you enter it via your EUI, some kind of a chat interface, right? The prompt goes in, right? You kind of look at various tools, right? Leverage, and then you have some examples, right? And essentially the whole system, right, leveraging functions, data stores, and extensions, comes back, with an answer. Some of these are, obviously Google first-party solutions like Google Places API, and so on, Vertex such API, but they can be something else also. And before we jump into the demo or walkthrough, couple of patterns, right? Again, these are not exhaustive, right? A collaborative system is basically, right, where a bunch of agents collaborate, right? They're at the same level. Think of it like a team, right? Like a team-based structure where, something comes in, right? Agent picks it based on its capability or based on like, if it's more of a scale out system, right? And then do the task, put it back on the queue, and you're done with it, right? But then if you have more like a supervisory type of a system, right? It's more like a hierarchical, right? Oh, hey, and we'll talk about this very specifically in a couple of minutes, right? Where you have a specific functionality, right? You invoke that, and then, a bunch of things get called, and they support that functionality, right? And then you can have a mix of things too, right? Then you have other patterns like competitive pattern, right, where you provide a task, right? And I think we'll talk about it in the evaluation side of evaluation topic, where you provide a task, right, and then multiple agents like kind of vie for it, right, and they do their job and come back with the results, right? And then you kind of compare, right, which one is effective, and an arbitrator might decide, oh, I like this responds better, and then you pass on the response, right? And there are like all sorts of hybrid combinations. There's no like definitive list, right? This whole thing is evolving so rapidly. At the end of the day, you basically create what works. I'll just cover one or two slides, and then I'll jump into a demo/walkthrough. From a Google Cloud offering, right? So we focus on three different segments, if you will, for agents. One is like, yes, even non-developers can use it, but think like, basic developers who don't want to or situations where you don't want to do a lot of hands-on coding, right? So pretty straightforward, you can set the rules and so on and so forth, right? Which is Agent Builder. Then you have low code API, right? Which is, you have an SDK kind of a thing, right? Now you're not building everything from scratch, right? But you have APIs that you can take care of and call them, and then it does, accomplish the task for you. And then finally, you have, more code first kind of solution, like for example, reasoning engine, right? Where we have like LangChain supported, native LangChain support, right? From Google. We obviously have Agent API as well, right? Where you want to build everything a la carte. Maybe for some reason you're interested in using open source, frameworks, and you want to use this. We have support for that too, right? As you might have already discovered, right, over the last few sessions, right? At Google Cloud, we strongly believe in helping customer where they are. So if your use case makes sense, either because you've made investments in an open source technology, you want to continue with it, or some other reason, we have support for that too, right? This is kind of a high level flow chart, right? Again, it's not super exhaustive, but talks about what the flow should be. With that, let me go to a walkthrough. Maybe I'll have to switch my screen. Give me 1 second. So I'm switching my screen. Hopefully the studio team is able to show it. Looks like, right? So I have one example here, right? Obviously, Naresh went through how to create a basic agent and so on, right? So what I've done here, right? So think of this, right? This is a mock use case for a customer support for a ISP, right? So when you think about customer support for an internet service provider, right, there are a lot of functions, right? If you might call customer support, right? Maybe I want to set up a new service. Maybe I have an issue with the modem. I want to return the modem, or maybe I want to leverage a promotion, right? They're offering a discount, or I want to complain or escalate that I'm not getting enough bandwidth, right? Or maybe now I want to schedule a repair personnel, right, to set up, I don't know, the last mile, right, the fiber or whatever coming into my house. So the idea is there are a lot of tasks, right? In a traditional a call center / support scenario, what you do is you'll call someone, right? They'll pick up. You have to explain everything from the beginning, right? Like, oh, whatever, right? We all experience this so many times, right? So I'll not walk through it, but the idea here is using agent, how can we make this whole experience extremely preemptive? One, right? When I call, right, or when I chat, the support system already knows who I am, right? And is able to look at my previous history, right? And get all the information that they have. And then basically know that, okay, maybe I'm a customer, I'm trying to do it for the first time, or maybe I have a billing issue, right? Maybe the billing failed or whatever, right? So on and so forth. Or maybe let me expand this, right? Maybe I have already filed a ticket, right? And I want to get information about that ticket, right? I don't have to explain, right? Most of the time we spend 10, 15, 20, 30, whatever number of minutes, sometimes multiple calls, right? The idea is to have this all integrated, right? So in this case, right, let me start with like, the function, right, function calling. So in this case, right, for connecting into, let's say, a customer using Microsoft Dynamics, right, I'm just taking one third party, right, so that that it's not all Google, right, we support other data sources as well, right. So what you can do is then, you can create an open API spec, right, where you're calling like, that third endpoint, right, with all the information, right, security, whatnot, right, you provide all that information, right, and then basically you pass, right, your user ID or customer ID, right? And then basically you get the ticketing information. So what happens is like, when you call, right, the router takes the call, right? So this is your entry point, right, in a multi-agentic systems, right? So when I mentioned last time, right, that this is going to be a hierarchical type system, uh, so the first call goes to this, right? So you say, whatever, right, hello, right? You provide the information, right? Like you're saying your whatever, right? I'll not read this whole thing. And then you're kind of giving the rules, right? Like a high level, right? Again, um, this 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 high level support kind of is like a guideline that you're providing, right? You can actually let LLM make this call, but you want it to be like a little bit more guided. So what you're trying to do is you're saying, hey, if customer has a general support questions, call this agent. If the customer has billing questions, call this agent. If the customer had technical support question, whatever, right? I'll not go through everything. And then within the each agent, what you're doing is like, for example, right, if I go to like support, right? So let's say I go to tech support, right? I have this data store, and what is this data store doing? The data store is actually going, right, and looking at the KB, right, knowledge base for the support articles, right? So ingesting all the information, right? When you say in a chat like, hey, I have this question about modem setup, it already has information about it, right? It's going to pick up that information and respond back to you, right, in a rapid manner. So what we are trying to do using agents here is that you're significantly cutting down the interaction that is needed to explain your case every time, right, to the support agent that you're calling, right? And these agents are basically um, helping the customer support team, right, to get this done ASAP. Right now, you can expose this directly, or you can kind of create this as a helper to the actual support person, right? In both cases, this thing works, right? So from a data perspective, right, I think there are multiple data sources you can have, right? I think as I've shown, like, you have APIs, you have database connectivity, right? For example, you want to like connect to a specific data store, right? So you go to a data store and say what kind of data store you want, right? So you have structured, unstructured, you can connect to like website content, you can connect to cloud storage, you can do like a API, then you have connections to BigQuery and so on and so forth, right? I'll not walk into everything given the time, but the idea is you have connectivity via agents and via functions and extensions to get in and get all the functionality. Now, this is kind of a no-code option, right? Now, what if I want to automate this via code, right? So there are, some GitHub examples. Like if you go to like the Google Cloud Generative AI, I've provided some links, right? So you should be able to see the links and do some of these notebooks yourself, right? But there are links where you can do it programmatically, which is pretty simple and straightforward, right? And finally, we have one not collab, like one Cloud Boost lab, which shows you how to invoke the reasoning engine, right? Like that's like a full code using LangChain, right? If you're interested in those kind of scenarios, I would recommend you to kind of leverage that, right? So let me kind of go back to the slides since we're running a little late on time. And jump back to my presentation. Hopefully this is visible. For the studio team, please switch me back. Yeah, looks like I'm in there. So yeah, this is another walkthrough, right? Anyway, I'll not go through this. We have the collab, right? So you can obviously walk through this, right? This shows how to build an agent using API, right? What I've shown you earlier was like, the UI based walkthrough. This is more like API walkthrough. You can do that. Now let's turn the switch the track a little bit, right? Yes, with generative AI, right, especially with the large language models, things have become so simple. I think Naresh mentioned this analogy, right, like of a car, right? You have a key and whatever, right? But the challenge is actually driving it safely to accomplish the goal. That's a core challenge. Now you can throw like a question to an LLM, right? And LLMs can answer like, kind of okay, with may not be 100% accuracy or consistency all the time, but they do respond back. But that's basically a very high level functionality, right? It's not even a POC. So when people actually start implementing in production, they get into a lot of challenges. And this is some of the data points, right, where you see that the productionizing, right, is not always successful. And the reason for that is some of these challenges, right? Again, right, this is not an exhaustive list, but everything from like how do you get your data, right? How do you make sure the data source is accurate, right? How do you make sure the data is clean, right? Some of these are also applicable to traditional machine learning, right? Then figuring out like models, right? Every model has its own kind of characteristic, right? And certain strengths and weaknesses and so on and so forth. How do you kind of consistently get? And one of the other challenges, the models change, right? Even in a given family, models change. And when models change, you have to make sure that your prompts are accurate, the results that you're getting are accurate, you're trying to evaluate them, and so on and so forth. Then you have scale problems, right? Like again, from a startup perspective, right? Let's say you have done your MVP, right? But you want to scale, right? Um, you need platforms that help you scale effortlessly, right? To a certain extent, where you don't have to kind of do your own uh, on your own, right, for everything. Then you have things like operations, security, privacy, right? I mean, you get the idea, right? The idea is there are a lot of things in addition to just like sending a prompt to an LLM and getting a response, right? And that's where productionizing challenges come into picture. And we'll walk through some of the tools. Again, this is not meant to be an exhaustive list of all the services Google Cloud provides, right? I mean, just take that with a grain of salt, in the sense it otherwise it would be like a big slides list with all those features. I'll cover some core areas that might be relevant to startup, and then we can go from there. But if you look at this span, right, I mean, from a point you have a basic prototype, right, like, or a POC, you have to deal with all these things, right? Like from uh, tuning your prompt to orchestration, right, using like these reasoning frameworks, right, React and so on and so forth. Then how do you continuously tune your model, right? Whether it is something like adapters and LoRa to like RLHF or full tuning, right? I it's probably not a very common scenario, but there are scenarios where people use it. And then basically adaptation criteria, right? And then evaluation criteria, and so on and so forth. So you have to pay attention to some of these. We'll go through the details. I think covered some of these earlier too, right? So let's start with provision throughput. So provision throughput is basically where a service where you get consistent response, right? Think of it like what do you call, like an expressway, right, on a freeway, where yeah, I mean, you can go at a certain speed, right, on any lane, right? But when traffic get clogged, right, you still want to, you need a way to kind of go quickly, right? Then you pay some extra money and then go in like whatever fast lane or whatever these are called, right? Express road. So think of it like that analogy, right? It's not going to help you get like faster, right? Like if there's a speed limit of 65, it's not like you're going at 120 miles per hour, but it ensures that you can at least go at 55 miles per hour, right? Maybe if I put that analogy, right? But in this case, we have SLAs, right? So whatever we say, you should be able to go at that, like get that queries per minute or tokens per minute or whatever metric that we are following. So basically, what happens is we do a reserved capacity, right? and provide assurance that the requests are processed, right? You don't get these errors. I'm sure, like you might have periodically seen, like during very busy hours, right? These 400 errors, right? Which basically say you'll not get response in a timely manner. And then you have predictable fixed cost. I think this is really important for startups where you initially have, like set of customers, right? And you want to give them the best experience, right? Randomly, if LLM calls fail, right, because of traffic or whatever reason, right, you would get pretty bad kind of feedback from your customers. So it's really important to kind of make sure that the throughput that you're getting is consistent, and especially for like multi-agent systems where you have dependencies across systems, right? The previous agents work fine and you get the response back. Then there's context caching. I think Naresh kind of touched upon a little bit, but the uh, challenge, right? Again, Google offers, at least for Gemini, we offer up to 2 million tokens, right, in context. And it's really great. I've spoken with a lot of customers, right, where they were doing a lot of RAG, right, to kind of get data in. Again, I mean, it's not meant to say that, context cache, the large context window kind of eliminates RAG, which is not the case. But at least, it gives you capability to ingest a large volume of context, right, and process. But if you try to do it iteratively over a long time, right, tokens cost money, right? Yes, I mean, if you just do a one call, it's insignificant, maybe, right? But when you do again and again and again and again, right, maybe you're pushing some video, or maybe you're pushing some, I don't know, for a claims processing kind of a use case, right? You're passing, like the claims policy document, right? Or you're doing some video analysis, right? And you're passing this video. Passing that kind of a context every time basically means, one, you have latency, right, because it's still data, right, that's kind of going in. And two, because you're being billed by tokens, right, you're paying more. So what context caching does, it helps you cut it down by caching the context that you're sending, right? I think, again, we've seen this slide, but the part that I think we're trying to convey is both cost as well as the performance, right? Now, from a limitation perspective, yes, there's at least, you need to have 32K tokens, right? You cannot cache, small requests, right? But still, for situations where you need to cache like large contexts, this can be great. Request size, there's a limitation for request size, right? Again, right, but you can use like cloud storage to pass like larger blobs and so on. The other limitation is a lifespan limit, right? So you can't have the cache time, right? Minimum time to live less than a minute. But again, right, these things are evolving, right? It's not set in stone, they keep evolving. So I don't want like you to be hung up on limitations, but again, try to think more about like the concept and how these can be leveraged. Again, I'm thinking more from like startup point of view, right? How can you leverage some of these where you don't burn your cash or credits or whatever it is, right, but yet get the benefits. The third point that I wanted to highlight was the evaluation framework, right? This is absolutely critical for those of you who have done, a bunch of GenAI-based applications or startups know this very, very well, right? It's one thing to pass, some prompt to an LLM, get a response, right, and feel like, oh man, like this is working fine, we'll go ahead, right? And then, all of a sudden something changes, right? The fact that the LLMs are non-deterministic, right, adds to a lot of complications, right? The same prompt with like a period or a comma or full stop make a whole lot of difference. And this is not just about prompts, right? It's about tasks, context, like criteria, your end goal. All these things kind of go together, right? So the evaluation kind of goes all the way from the first prompt you give to the first model that you select to like identifying the changes to the task and the prompts and so on and so forth. And as the image shows, right, it spans across, right? So we do provide a bunch of services that are useful, right? I'll talk a little bit about it in the coming slides, but Fundamentally, these are like, different criteria, right? Obviously, the evaluation works both on Google Foundation models as well as like open models, right? And then we do online, and batch is going to come soon. We have what is called as point-wise, which is more like based on calculation, and pair-wise, which is mostly like comparison between two models. And then from a service perspective, right, you have computation based, right, based on certain definitive logic or formula, and an autorator, right, which is basically comparing two models together. Like, for example, there's a arbitrator model, right, like a big model that sits there and evaluates both other models and says like, hey, which one is generating an accurate response, right? So maybe this is one use case where you can provide to the what do you call the competitive agent scenario that we have given. So both have their own benefits, right, and advantages. So you have to like really look at the use case, right? There is a documentation link that I've provided. It kind of talks about all the metrics that we support out of the box, right? And then the arbitrator model kind of does kind of comparison for both. Point to be noted here is like giving your data, right? Giving examples and outcomes is the key. And also one point you need to understand, and again, it's like any other thing in the LLM world, is the arbitrator model that you have that you're using, right, would also change, right? So you should always think about, okay, keeping things up to date, right? And then evaluating periodically to make sure, right, whatever outcome that you're expecting, you're actually getting, right? So I'll skip some of these, right? But as I mentioned, like, we have this feature called rapid evaluation. Some of these names would change, right? So this will be part of evaluation service, right? I think we may discontinue the rapid evaluation name, but the concept still remains the same. And auto side by side, what used to be called as auto side by side, is now called as auto rater, right? Again, as I mentioned, this compares like output from two different kind of models, and then tells like which one is more accurate. Finally, I want to touch upon security and compliance, right? Especially for startups that are in like, more restrictive areas, right? Regulated industries, this becomes much, much more important. Not to say that the consumer apps are not, both are, both need to be secure, both need to comply, and so on, right? So we do offer, a few things, right, across like data, model, application, and infrastructure. One of the most prominent one is Model Armor, right? This is basically a tool or a service, I should say, that protects you from various things, right? Like prompt injection, data loss prevention, and so on and so forth, right? It's a set of services that you can actually go to the console, right? And it's as simple as like checking the boxes, right? And then you pretty much get that functionality. And then the broad set of foundational features, right? Enterprise features that we have that cover indemnity, which is basically like, if the model returns something to you, it's a guarantee kind of thing from Google that like, we cover you, in case, let's say, there are IP issues or whatever, right? I mean, there's this specific information about it, right, in the links. You can go through it. Then compliance support, right? Especially if you're working in an enterprise type environment, right? Making sure that you have like right VPC controls, audit controls, and so on and so forth. And most importantly, I think cost is also very, very important, right? Like how do you use dynamic work scheduler to provide that cost analysis and provision throughput. And then finally, responsible AI. I mean, this is very important, right? No matter where you're working or where your solution is working, making sure that, there's no bias, you're doing all the things that you need to do to make sure the services or, the applications that you're building are compliant and working as per the expectations. So I did mention about indemnity, right? So again, I'll not go too much into details. You have a link, you can go through the details. And then the sovereignty of the data, right? So we do support across multiple regions in the world, right? So if there are data sovereignty problems or concerns, right, even from a model learning and tuning and all that, right, so you have a pretty good set of options. And finally, there's an R policy, right, where you can say like who can access what aspects of the model and so on. At least I think we need to give some time for questions. So here are a few links, right? I think some of these that we have talked about now. I've also shared a lot of collab notebooks as well as the cloud skill labs that you can go through, right? So with that, let me stop here and pass it on to Erin, and then we'll jump back to the Q&A. Thank you so much.
Awesome. Thank you so much. Another great session. Let me just see if I can get my slides back up, but Maruthi will give you a quick breather. And while we do that, I wanted to draw everyone's attention to the Google for Startups Cloud program. Um, so as you're starting on this learning journey and training with us and all of the Google Cloud experts, we're pretty confident that you'll want to try some of the products and solutions that you see referenced throughout the program, many of which were covered by Naresh and Maruthi today. So if you are a startup, you can apply for up to $350,000 in cloud credits via this program, and you can start building your Gen AI solutions for your business right away. So we have various tiers to the program. We start with a $300 free tier. We move into a $2,000 start tier, and then we have additional credits to support growth and scaling. So for example, we have various support offers for every different stage of startup, including tailored offerings and programs for AI first and Web3 companies. So if you're interested, please do scan the QR code that you see on the right side of the screen. You can also visit the link that's there as well. And we have also pinned this in the Q&A section below the video. If neither of those work for you, it will be in our follow-up weekly recap email as well, in case you're not ready to look at that today, but maybe might be at a later time. All right, just two more quick things and then we'll get into Q&A. If you haven't heard, we listened to your feedback from anyone who joined in Q1 and Q2 this year, and we're really excited to announce that we do have a dedicated Discord community channel for you and your teams to continue the conversation with your fellow attendees and peers. We know that there's a lot of chatter going on in the chat space and Q&A during the live sessions, and so this is a way to kind of keep that going. And if you have questions, we have Google experts online as well. So feel free to join using the QR code or the link. We'd love to see you there. And last but not least, we would love your feedback. This is incredibly valuable for us. Please do share your thoughts. It takes just about 2 or 3 minutes about how we can improve, how we can continue to making this even more valuable for you. I promise we read your feedback and we do try and implement it moving forward. So I know our speakers appreciate the feedback, and we also appreciate the general program feedback. All right. With that said, let's invite Maruthi and Naresh back on. I think we probably have time to hopefully cover a few questions. So we'll go ahead and move into those. Thank you both. Just a few more minutes. I know you guys have had a long session today. All right. So we have a question from Andrew. Can you chain multi-agents in Agent Builder to create agentic system?
Yeah, I can take that. So for now, right, I mean, I've explored that, but I won't say like it's super accurate. Sometimes, it kind of gets into, there's a depth at which, it starts getting into the wrong loop, right? What I recommend right now is if you have more than like 2 levels of looping, maybe agent builder is not the right solution, right? You can look into, let's say, a reasoning engine, right, which will have like pretty exhaustive support because you're kind of dealing with the code, right? As long as your chain, right, whether using LangChain or other solutions, right, you have built it well, you'll have more granular control, right? And again, right, this is purely based on my experimentation that I've seen, right? Of course, the technology is evolving, right? Obviously, we also have Agent API, right, which is like the third in the middle kind of a solution that I mentioned, right? Expect some more announcements like in a month or two around that use case. But your specific question, right? Anywhere like beyond like 2 levels, right? In that nested hierarchy, probably that's where I would like take a more deeper look and think if analyze if reasoning engines is a better option. I hope it helps.
Awesome. Great. Let's try and get through 1 to 2 more. So this one is from Kelly. If you are not using a model to build your agent, can you just use RAG with your own data and fine tuning?
So building so I'm sorry, I think I need to kind of I lost the context. What was that? If you're not building a if you're not using a model to build your agent, yeah, can you use RAG with your own data and fine tuning? See, I mean, you don't have to use a model, right, for an agent. But again, right, when you're using RAG, you're in a way like as part of the RAG system, right, you have model coming in there. So strictly by definition, you don't need to have a model, right, in agent, right? You can have more like a deterministic flows, right? But again, like if you are actually using that functionality somewhere, even in the model, you're not getting out of it, right? So hope that clarifies.
And a quick add to that, fine tuning is generally done with a base model. So you add layers of data on your base model. So I wasn't too sure on the question because RAG, yes, you do a vectorized representation of your data. And then when you do a search, you would need some kind of a model at the end to respond in a generative AI way.
Yeah, I mean, there's the embedding, right? And you need like, some kind of a search functionality, right? So it all depends on the use case, right? I think if the question was more like to say, hey, no, is a model LLM really needed as a part of agent? Yeah, the strict answer is yeah, it's not, right? But then what you're trying to do is more important.
Awesome. All right, I think we have time for at least one more, so let's try. So this is from Jian Long. I apologize for any mispronunciation. So they say I tried image generation with Gemini Advanced, and it seems like spelling isn't accurate, i.e., there were many spelling errors. Is that the case?
So let me take a stab at it, and then maybe you can follow up, Naresh. So I'm assuming that when you mention spelling errors, it's spelling errors in the generated image, right? And that used to happen, right, if you're using the older version, right? But the latest version, which is in the preview v3 for editing, if you try with that, it has significantly improved. In fact, that's one of the core strengths of this latest model, is that like the text that you're using, right, as a caption or as an overlay, whatever, right, it's significantly better compared to like a lot of comparable models. So if you've not already allow listed, I request and recommend like giving it a shot, right, and trying it. But I do acknowledge, right, if you're using old models, yes, there are instances where you'll have like a lot of spelling mistakes, in the image that's generated. So that's not unheard of.
Exactly. And just to add on top of it, absolutely, as Maruti said, acknowledge that there were spelling errors. Imagen 3 is better, but with the previous models, if you're continuing to use it, if you put anything in double quotes, most likely than not, it comes up back again, right? Or maybe if you say edit it in the editing feature, you can add your own text. But again, there are a lot of errors in the previous models. Absolutely correct.
Okay, awesome. Do you guys want to try to fit in one more? We've got about a minute left.
Sure.
All right. So we got this one. They ask, what ways do you support health agents to meet HIPAA and other health laws and regulations?
So we have a tuned model for healthcare, right? I think it's called healthcare LM, something like that, um, which is targeted for like healthcare use cases. I'll have to come back on like the regulations aspect, right? On what regulations are already covered, but that model is highly tuned sorry, it's called MedLM, not HealthLM. MedLM, that's highly tuned for healthcare use cases, right? So I can provide some link, or maybe you can just search up on MedLM on like, the what do you call, like the compliance requirements around healthcare sector.
Awesome. All right. Well, I know we are at time. Thank you both so much for another great session today. Just as a reminder, next session for everyone is on Tuesday, November 12th. Next week, we shift focus a little bit to BigQuery and Gemini, so it should be pretty interesting. So Tuesday's session is about simplifying data exploration and boosting your productivity with Gemini and BQ. So we hope to see you there. Maruthi and Naresh, thank you both so much for such a great session. Have a great day, everyone.
Thank you.